All right, good evening, everybody. On today's stream, I just wanted to mess around. I went a little deep last night on TLS certificates, like messing around with basically how to do HTTPS on the ESP32, but also messing around with how to. My eyes have been open to the fact that mbedTLS can be massively configured depending on your project needs. And so I just want to mess around with those settings and do some comparisons and things like that. So that's what I will be doing. This is going to be pretty freewheeling. A couple things. First off, out of the box, I believe on the ESP32, you have mbedTLS, where you've got My SSL that you can use for HTTPS. The default is mbedTLS. And so that's what we're going to play with today. I've not messed around with My SSL, but it'd be awesome to do a deep dive on the differences between the two. And um, I remember seeing a breakdown somewhere about one being, how they compare with ROM and RAM usage and things like that. But anyway, gonna mess around with mbedTLS. So let's get started. So what I have done here is this is just the grossest code ever that I just cobbled together. Um, Make it a little bigger because people have asked for that. This is a combination of code I've written before and the Espressif docs like examples. So let's just go here really quick. If you come in here to, I believe it's API reference, yeah, ESP HTTP client, and then you can go to this HTTP client example. I'm not a huge fan. I know why they have their examples done like this, where they share um, this like common components thing. But anyway, it's hard to just come in here and copy an example without like cloning the whole example. And I guess it's part of the IDF, so you go in there and open it up. But anyway, it's not how I normally do it. So anyway, it's really just this sample, which if we come into really quick, is like a whole lot of lines of code, like almost 1,000 lines of code, 823. I stripped all of it out down to just making an HTTPS call. And so after connecting to the internet, so I have like this helper function that connects me to the Wi-Fi. Sorry, not the internet, the Wi-Fi. And then the crux of the example is HTTPS with URL. Is this right here, where we're just going to go to housemyssl.com and do a check. Now, what's really cool about this, as I've been going a little bit deeper, I've understood SSL, TLS, whatever you want to call it, secure internet. But when you're running an embedded device, there's a lot of differences than from when you're running in a browser. And so let's just go to this site really quick to show you what it says. It says your SSL client is probably okay. And then it gives you a bunch of stuff like your client is using TLS 1.3. Now, my client being Brave in this example. And then it talks about this ephemeral key support, TLS compression, session ticket support is good. Insecure cipher suites. Oh, I'm going to come back to the session ticket support, I think, as we're messing around. And then given cipher suites, the cipher suites your client said it supports in the order it sent them are, and then it gives you what the cipher suites are. Now, this actually you might not think is very important, but was the reason all of my puck holder products went down about a month ago because something changed on the server side. The TLS version and the cipher suite order that the ESP32 was sending, and I didn't really mess with anything, I was just using out of the box settings, triggered a different cert than what I was expecting. And so it's actually hugely important when you're trying to optimize. And I'll show you what I mean. So, first of all, I'm going to comment out this cert PEM. So this is just, we're connected to the Wi-Fi. Get all these pop-ups out. And we just set up this ESP HTTP client config with a URL and an event handler. The event handler is just going to, show us some information about connection, getting data, and then it just spits out the data that we get. I'll show you that here. On finish, I just have this like print output buffer that it's been building up the whole time during the connection. We do the client init, ESP HTTP client perform. You can do this async or synchronous. By default, it's synchronous. And so it's going to, on line 253 here, it's just going to stop, make the request, get a response. And then if everything is okay, it'll show us the status. Otherwise, it's going to say error performing HTTP request, clean up the client, and then exit. So I've commented out the cert PEM. Let's save that. For this example, I'm not going to be able to pull this up in front of you. All I'm using is a dev kit C board. It's just a little ESP32 dev board. Nothing fancy about it. No custom hardware. Straight out of the box dev board. Okay, so let's come down here and let's do a flash monitor. Let that build. And we will get an error. It's going to connect to my Wi-Fi, and then it's going to not be able to hit How's My SSL because we have a bad configuration here. But let's just show what that looks like. Okay, connected, and then here you go. We got this no server verification option set. So mbedTLS is basically saying, I don't have a cert to validate this TLS connection with. So, fail. And so this is the error perform. Like, this is just, you can tell I copied the example code. Error performing. I would also put a colon here. Okay, sorry, I'm not going to nitpick the expressive sample code. But anyway, you can see that it fails. Okay, now, the other thing I want to mess around here with here is how we can pass the cert. And so I'm going to uncomment cert PEM. So we're going to give it a cert. And what this is doing is when it makes that connection, that TLS handshake, it's going to use this cert to validate the server that we're connecting to. And in this case, this is just the How's My SSL or How's SSL cert, their root cert. And so it is just, I have it as a just defined straight up in the source code as a C string with new lines here, okay? And what else was I going to mention about that? Let me come back to the code here. Oh, you notice I have this -a-check. What's really cool about How's My SSL is, let's grab that. I just came to howsmyssl.com, but if you use this a check, it returns the exact same information in JSON. So if you don't do that, it's just going to splat the HTML and it's super long. But if you pass this URL specifically, you get it in this format, and so you can see where we are, like TLS version 1.3. It gives you the list of Cipher suites in the order, so that we'll be able to parse that, in our example here. So that's what the A check is. Okay, so that's how we're going to say, here's the cert to use. We're going to save that. And then we're going to exit out of here, idf.py flash monitor. Get a whole bunch of warnings, which we're going to ignore for now, and see what we get. So this time it should, if I've got everything right, it should connect. And this is going to be our baseline. Okay, cool. There you go. See this? We get all this JSON splatted out. It connected, and then it tells us, the status was 200 and the content length was 2545. If you just hit raw howsmyssl.com, the length is like 15,000 bytes, like somewhere 14K. So So anyway, much shorter, and then we can actually look at it. So as we maybe play around with settings, we can see some of these things change. The nice thing about this is How's My SSL rates us as probably okay, which is the same as the browser and like all of the major, where was it like, there was a couple of, oh yeah, like beast vulnerability false. We're not susceptible to that. And so, you know, all in all, the default out of the box configuration, and I've changed nothing here in menu config, is pretty good. I like this. We're going to mess around with this later. Where was it? Ephemeral key support, session ticket supported, true. Okay, so what I want to do now is we're going to exit out of here. And we're going to make a new directory. Victor, map files. And what I'm going to do is I'm going to copy build. I don't even know what the name of this. I don't remember what I called the project. Oh, ESP32 production template. Yeah, I'm using this. Okay. ESP32 production template map. We're going to copy it into map files as baseline.map. And the reason we're going to do that is we're going to do some comparisons as we go along here. Okay. So I'm going to copy that. And then while I'm here, I'm going to do an idf.py size components. And this will tell us some information about the size of our binary. So total image size, 870,000 bytes. And then here's a breakdown. It sorts them, I believe, in the flash total descending. So libnet 802.11 is taking up most of our space, but right behind it is lib embed crypto. So that's going to be embed stuff. There's an mbedTLS down here. I think there's a couple of more. And what we can actually do is we could do an idf.py size components and grep embed. And now you'll see all together, we got 122 plus 31, 150, 158. So around 160K, we'll call it, of flash space is coming out of the embed stuff. And so I just want to mess around and see, how we can change this. So as we're going through this, the baseline here, and maybe let's just create a new file, notes.md. Okay, our baseline is 870,429. Okay, so that's what we're starting from. I wonder if we should. No, I don't care. I'm not gonna track. We're just gonna do total. Okay, so the first thing I want to do is see if there is any difference using the method of adding a cert through make. And so let me tell you what I mean there. So if we come up here to the certificate, you can see, like I said, I just have it as a string here, but I also have it right here. So, just kind of take a mental snapshot of that, and trust me when I say that this SSL_cert.pem is the exact same certificate, just as the raw PEM file that you would download. And so another way we can include this is through CMake by doing like an embed file, and then there's some, I'll show you what I mean. CMake lists. Is it here? Oh, it's in here. CMake list. Yeah, here we go. This embed text files in our component. So let's take that. Let's come up in here into our main CMake lists. And right here in our IDF component register, we're going to come down to a new line and do that. But ours is just SSL. SSL Cert.pem. Okay. And the way we include that, you'll see there's this syntax right here. This is just like it says, to embed it in the app binary, the PEM file is named in the component make, component embed text files variable. That's how we do that in CMake. And then I don't even know if the end is used. End. Yeah, it's not. So you don't even really need the end because you just use the start. So let's grab it. And then back in our main file here, let's just get rid of everything else. Just right up here at the top. We did that. Now, you have to name this. Well, sorry, you can name the variable whatever you want. So I'm going to name it cert. And then what I'm going to do is I'm going to comment this out. Okay. So I'll name it cert, but then this naming here is like very specific. So you have to have this underscore binary underscore, and then it's the name of the file, and then underscore start. And so it's, let me just show you. And then with the extension. So in my case, it would be, I believe, SSL underscore cert underscore PEM underscore start after this underscore binary. So like that's we come back over here to the CMake lists. I'm embedding it as just by its file name. Then that gets this embed text files, and you could look this up in the source, is going to turn it into a reference that looks like this, that'll have a start and an end. Okay, so it'd be a miracle if this works, and I haven't screwed something up, but let's try to build it and see what happens. I feel like it might hate some warnings being treated as errors. What is it? It's not that. It's not that. Not that. Warning, 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 warning. Where's the error? Oh, W error. No. Multi-line comment. It's all commented. I don't even know why these are here. All right, help me out here. These are all warnings. Warning, 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 warning. This is saying error. Multi-line 35. Am I missing? What am I missing? Oh, I wonder if it's because I made a change. It doesn't know where this is because I made a change. Let's go full clean, and then build from scratch. Oh, I know what's happening. I know what's happening. That's not going to help us. Multi-line comment. I've got these these continuations. Yeah, okay. I'm honestly not sure what the syntax is here. Can I do something like this? And then like that. Let's try that. Okay, there we go. Multi-line comment. The compiler tells you what the problem is. You just got to be smart enough to translate it. Okay, so let's first of all see if this works. Pulling in the cert this way. So I've commented out my cert string there, and it should just be using now this built into the binary using the special, CMake ESP32 syntax. Let's see what we get. Okay, yes it did. Okay, so that works. So the new version of this, that worked exactly the same. I got the same response and everything. Everything works. TLS looks good. Okay, so now let's do a size components. We're not going to grep embed. And let's take a look at the size. I imagine it's not different, but let's see. 870, 429. Exactly the same. Okay, so the total image size. So we're going to call this I don't know what else to call it. ASM, or let's see. Let's call it embedded cert. 70, 429. Okay, so those are identical, which I expected. So what we're going to do is we're going to copy, build ESP32 production.map to map files, embedded. And I'm going to call this 1. Like I'm gonna number them 1, 2, like as I go through. So we're incrementing. And then what I should be able to do is an idf.py. No. How do I do it? There's a way to diff these, and I just have to remember how to do it. Standby. I gotta refresh my memory. How to use idf.py size and then do a diff. It is idf size.py. That's what it is. Okay, so it's idf underscore size.py. You can do a diff, and then we do map files, and we'll do baseline, and then we'll do map files, embedded1.map. There we go. Okay, so this is just a little thing that you can do. It'll tell you the current is embedded, the reference is the baseline, and that will change based on the order that you pass these. So if I had passed embedded first and baseline second, then embedded would have been the reference and baseline would have been the current. But anyway, and then it says the difference is counted as current. So the new one minus, in our case, the baseline. So the difference is nothing. Like it built exactly the same. I mean, maybe not binarily bitwise the exact same binary, but for all intents and purposes of size, it built the exact same binary. Okay. So cool. So now what that allows me to do is think about which method would I want to choose for my projects? Because now I know I can do it like this, and that works, or I can do it like this. Which one do I prefer? And, you know, it's an interesting question. I don't know. I do like being able to just drop the file in and not have it be a code thing. But I also am not a huge fan of this like song and dance. Like, this is a very, now we're coupling to Espressif's build system to get the cert in. So just saying that out loud, I convinced myself I would, even though it's a little bit of a minor hassle to format it this way as a string, I would prefer it. And that's how I've done it in other projects. I have it be in its own separate compilation unit file, and then I include it. And so I don't think I would do it this way because, again, this is tying, it's not very portable. That's what I'm saying. Okay, cool. But anyway, um, do whatever works best for your project, knowing now that there's no difference. You can do it either way, and it's the same. Okay. But now the thing that I really want to start messing with is some of the mbedTLS stuff. So now we're going to get into IDF.py menu config. And we're going to have to move that up. We're going to go to component config. And then this is where you would come and configure mbedTLS. Okay. And as you will see here, there are a lot of options. And when I see this, I mean, it's just not dials and knobs and levers and just a lot that you can change. And so there's room here to do a lot of optimization, whether it's RAM usage, ROM usage. And if you go to mbedTLS's site, they give a whole thing on like, here's what you can do to lower RAM usage. This is what you can do to lower ROM usage. And so you can tweak this thing to your heart's content. And that's the thing I'm interested in. Like, how do we do that? Still get what we need, and how does it affect binary size? But the first thing we're going to start with is this certificate bundle. And it says enable trusted root certificate bundle. Now, I'm not using it, but I don't know if it's being built in. And so what I'm going to do is I'm going to turn off this trusted root certificate bundle, and then we're going to talk about it for a second. I'm going to say yes. I'm going to do a full clean. But that's not going to matter. I'm going to remove SDK config because I wanted to build it from scratch. Well, no, it would have just modified it. Let's validate that. It's in a different folder than I normally put it in. Okay, certificate bundle, you can see it's still off. Okay, we're good. All right, .py build. So what we've done here so far in our example is we have a hard-coded certificate. We are hitting a single HTTPS endpoint, and we know what the root certificate is for that endpoint. And there's a limited number of root certificates that will allow you to reach 99 point whatever percent of the internet. Because let's give you an example. Let's encrypt. Let's do a quick lesson on this. Let's encrypt. Let's see if we can just get to it from the base. Certificate policy. Let's encrypt root cert. Chain of trust. This is what we're looking for. Okay, so let's encrypt almost, I don't want to say almost all, lots and lots of websites that have automatic SSL and TLS that you do through any hosting provider is using Let's Encrypt. There's some exceptions to that, but a lot of them, Let's Encrypt changed the game of HTTP to HTTPS by making certificate signing, ubiquitous. And so they explain how, like, hey, we have this active root X1, active limited availability root X2, and then they use those root certificates to sign these intermediate certificates. And I don't want to go into a whole history and lesson about how chain of trust works, but the point is every Let's Encrypt certificate in existence right now, for the most part, is going to come from this root, and we'll tie back to it. Just as a quick, let's just go to like deploythefleet.io. That's my site. And if you click up in here and it says connection is secure and you go to it and you're like, hey, show me this certificate, it's going to say, hey, the common name on this is the Let's Encrypt R3 certificate. Okay. We come back here. Oh, look at this. Active. Let's Encrypt R3. This is the certificate that Deploy the Fleet is presenting to clients. And this chains back up to the ISRG root X1 and X2. Okay, so just a quick lesson on certificates. Now, what you can do is you can just grab this. Let's just grab it in text. No, I don't like it like that. Sorry, not like that. It's gonna want to download it. Okay, anyway, when you download that, it's gonna give you something that looks just like this. Okay, and so if I was building my application here to connect to Deploy the Fleet, I could just grab that R3 or that root certificate, put it in my code here, and then right now I'm using the How's My SSL root certificate, but I could put the Let's Encrypt X1 root certificate in here, and then I would be able to make an HTTPS connection to deploythefleet.io. Now, when I did this in the past, I thought, well, that is what you want to do if you know you are only connecting to a specific domain that you own. So, if the point of your IoT project is not to connect to all of the internet, there's no reason to have a bundle of certificates. Like if you're connecting to a single site, you know what certificate that is, you should just include that certificate and you reduce your binary size. But I've found some interesting stuff around that. And that's what I want to mess around with right now. Like how much does it affect the flash size? And so let's play around with it. So what we can do is we can include ESP CRT bundle. I do want to just do a really quick make sure nothing changed here. 875.61. Help me understand that. Oh, okay, yeah. 875. Yeah, so we somehow got a little bit larger by doing what? I was going through that. I may have missed a step. Okay, I turned off. Well, yeah, what I did was I turned off the cert bundle and then I built it again. So it got bigger when I turned off the cert bundle. Now, I wasn't using the cert bundle, but that's super interesting. And let's just build it one more time. And actually, I wonder if I can just grep the total. Yeah, 875.61. Okay, and just to make sure I'm not insane, let's go back into menu config. Component config. I'm not going to change the source code at all. I'm just going to come back in here to certificate bundle and turn it on. Yes. Build. 874.29. Yeah, so I'm not crazy. Turning off the bundle, and that doesn't make any sense to me, and I don't want to dig into that. Turning off the bundle, even though I'm not using it, increased the binary size by, like 100 bytes. Turning it on and not using it was smaller. So let's capture it. Yeah, this is just, it's going to take time, but we gotta dive deep on this so we fully understand what's happening. Let's turn it off, save it, build it. And then we're going to call this bundle off, not used in code. $870,561. What we can do is copy that to bundle off 2.map, and then I'm interested in doing a so text, like it increased. Yeah, it's interesting. And you can see right here where you're getting the difference. Total image size, 132 bytes. So slightly more RO data, read-only data, and slightly less text. Okay, well, but now let's actually use the cert bundle. So I'm going to uncomment the cert bundle. I'm going to get rid of that. I'm going to uncomment out I'm going to comment out using the cert that way. I'm also going to comment out the embed text files, so we're not going to actually embed it in our binary. And then what we need to do is, this might be a lot of searching. Yeah, it is. Cert PEM. Down here, instead of specifying a cert PEM, we're going to do a .crt bundle attach, and we're going to attach the ESP CRT bundle. But in order for that to work, we need to enable the bundle. So down here in certificate bundle, we need to enable it. But now I just want to try something. I'm going to not enable the bundle, and I would expect it not to build. Let's try that. We're just messing around. Mess around with all the things. Now, I don't know if that no such file or directory is actually true. So we might have to include it. Yeah, well, it's in mbedTLS. Okay, which are we including? We are not. Okay, so let's include mbedTLS. And now try to build it. No such file or directory. All right, so I'm imagining that then that is because it's not enabled. So let's try that. It seems weird that it wouldn't be able to find the header file though. So let's enable the bundle. And now you can see you've got a bunch of options here. You can use the full default certificate bundle, use only the most common. Do not use the default certificate bundle, in which case I believe you have to, add your own. And then it'll tell you, oops, sorry, like the maximum number of certificates allowed. I guess it will choose. I don't know. We'll play around with some of these settings. So we're going to use the full default bundle. And the expressive docs tell you, like, the full one is the entire Mozilla bundle. It's got like 137 root certificates. But then there's like a subset of that covers a very large portion of the internet, which is not as many. And so let's see if it'll build now. Okay, it did. It didn't, but different message. It's saying the event handler does not match the declaration order. Let's do CRT bundle. Yeah. So this client config, we need to look at event handler. Where is CRT? Client cert, event handler. Why am I missing it here? Use global CA store. It's not that. Oh, is this changed in a newer? Event handler. Oh, yeah, right here. CRT. Oh, CRT bundle attach is after event handler. Okay. So all we need to do is move it from here and put it there. Okay. So that should build now. Okay, great. IDF.py. Now let's monitor. So now, again, I kind of waved my hand a lot there. I've removed the hard-coded string. I have not embedded SSL cert.pem. We are using the bundle now, the built-in bundle. And so first things first, let's just make sure we can still make a TLS connection to how's my SSL. It should, and then we'll look at the sizes. Look at that. Sweet. Okay, so that worked. I feel like the Cipher suites is so long. But anyway, it worked. Great. All we care about. Now, do an idf.py size, grep total. We got significantly bigger here. Let's come over here and say bundle on and used full bundle. And that brought us up to 934,193. And let's actually take a look at size components here, because I don't know where that would show up. I don't know if there's like a cert. Let's expand this way out. Libnet. Not sure if it would like if it's going to be its own line item or if it's a part of one of these embed. No, because it's an ESP32 thing. Okay, there's nothing there. So we could come through here and look. One of these things is going to get a bunch bigger or smaller based on us using that. But I don't know which thing. But let's do our copy. And we're going to call this full bundle 4.map. And from the baseline, we can see, yeah, a lot more flash. Presumably this is the bundle being in there, so like 60K or something. Okay. So now let's keep playing. This is great information. Let's come back into menu config. Component config. mbedTLS. And now in the certificate bundle, let's change this to use only the most common certificates. Okay. And let's see. First of all, I'm expecting it will still connect, but let's just make sure it does. Let's get a new line ready here. Bundle on. Most common. Used. Oh man, I feel like this stream could go for like hours still, and I don't have hours. Might have to pick this up. Part 2. But fascinating stuff. Okay. Perfect. So it still works. So that's our baseline. Great. Now, let's take a look. Oh, yeah, see? Not a whole lot bigger. Oh, I mean, that's a bunch smaller. 886.961. All right. And so you can see from our baseline of 870, you know, that's not a whole lot bigger. So, I mean, you're getting a significant savings there. So let's copy this and call this partial bundle 5.map. And then let's compare. I want to do full bundle 4.map to map files, partial bundle 5.map. Okay, so 47,000 bytes smaller. Yeah, because current, yeah, a positive number means current is larger. Partial bundle is current. It's a negative number, which means it's smaller. So 47K smaller. But if we come back to here and do a baseline and then do a partial bundle 5, you'll see from our baseline, we're only 16 more with the partial bundle, we're 60, yeah, what was it, 63,000 more with the full bundle. So big difference in flash size. And again, the baseline being I'm specifying a cert. Now, I just want to briefly go back. I know this is a long video, but I want to remind you, in one of my production projects that I have, I was doing this, pinning to a cert, and it bit me. And let me just show you really quick. How do I do that? How did I do it? So cert history. Wait, was that it? How do we? Oh gosh, I can't remember the name of the site. TLS Cert history. Oh man, I don't want to get hung up on this, but I do want to show you how it bit me. Okay, I got to come up over here into my normal browser. Find, yes, this right here. Okay, I found it. That didn't take very long. Bear with me. Okay, stat feeder IO is what my puck holders hit, and if you will look right here, this keeps this crt.sh keeps track of the cert that your site is presenting. And you'll see R3, 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 let's encrypt R3. This let's encrypt R3 was what I had in my firmware. Like that's what I didn't want to have the cert bundle because I thought it's way too expensive. Turns out it's not. Like you can use the cert bundle if you haven't noticed that, unless you're really cramped on flash space. But I had that in mind. But look what happened right here on September 12th. Uh-oh, it's now using this E1 cert. Completely different chain of trust. And so when my firmware was trying to say, oh, hey, I'm trying to connect to statfeeder.io, it's like, nope, I don't recognize that. That's not the cert I'm looking for. And all of them stopped working. They stopped updating. And you can see it. I started working with my hosting provider because it was an issue on their end. They were using Cloudflare, and Cloudflare changed how they were doing that based on the arguments that were presented by the client. And then they got it fixed back. Now it rolled back to R3. So on the 15th, all my devices came back online. But as part of all this research, I will be switching to the Cert Bundle. I've got the flash space. And in that case, that change wouldn't have affected me, but it did. And the out of the box, samples that you get a lot of times show this approach of put the root certificate in there. So something to be aware of. All right. I know we're getting long. It's been like an hour, but it's been a learning hour for me anyway. So one more thing I want to point out is one of the things that support told me when I had my issue was the order of these things presented and coupled with the TLS version that I was presenting is why it started giving me the E1 instead of the R3. And so this list of ciphers we can also control via menu config. And so that's another way that we can modify this. But one thing I want to try really quick, my original purpose was how much does the bundle affect it? And a lot if you're doing the full bundle, not much if you're using the most common one. And really it's just a matter of testing, like what sites does your what endpoints does your device need to hit will determine what certs you need to include in your firmware. Okay, the last thing I want to try is just to see something change here, which is tokens. Where was it? Session ticket supported true. Okay, let's come into menu config. Component config. I'm so glad I found this How's My SSL site. Like, really pumped. A lot of insight into how your device is connecting. And we have down here, if I remember, there is a session tickets. We're going to turn off session tickets. I think that's all I need to do. And then you can see down here, we can change the curves that we support. Oh, certificates, like, yeah, you can change this. See, like CSR parsing, I don't think we need to do CSR parsing. I'd be interested to know what happens when we turn that off. Which symmetric ciphers you will support. But anyway, I turned off tickets here, and I want to see, support TLS renegotiation. That was another one. But let's just, renegotiation is a way to reconnect faster on subsequent connections by saving some information about after the initial handshake. Okay, so this should be a full rebuild, but I'm expecting now to see that ticket be false instead of true like it was before. And we should still be able to connect. And so that's like a feature that if you need, great. If you don't need, turn it off. There's a lot of things turned on by default that I think a lot of embedded projects wouldn't need. And that's where I'm saying I think there is a massive landscape of customizing mbedTLS in your ESP32 project to suit the needs of your project and save on flash. Okay, cool. And now look at this. Session ticket supported false. So that was cool. It changed, which is what we were looking for. And I think we should be able to see that. Maybe if the history's old enough. No, with the build, it's not going to be, is it? Nope. Okay, but that was the change I was looking for. Session ticket supported false. And then there was one other, showing insecure TLS rating, ephemeral keys, TLS compression. And this is just the Cipher suites. Okay. And TLS 1.2. Okay, so it worked. Session ticket support is now false. Copy. So 6 is going to be, we're still partial bundle. Bundle on partial session ticket support disabled. Okay, so this is going to be no session tickets 6. And that, it was a little bit smaller. 885917. 859. Okay, so like 1,000 bytes smaller. What we're looking at. We can do, let's do this. Bundle 5. Let's look at bundle 6. Not files. What is it? No session. Yeah. So 1,000 bytes smaller. But again, It's 1,000 bytes. You know, these are things that you can tweak to. And I think for me, the biggest thing is the way I always start is get it to work. And then when you have the constraints, optimize later, right? So, you know, does that 1,000 bytes make a difference? Well, if you have 100,000 products and that's part of an OTA, I mean, you got to pay for that going over the air, right? So there's things like that that you know you will want to consider, but you don't need to start with. Like these aren't things that you start with; these are things that you figure out. But one of the things I am really fascinated in is what features do I need, but then what's the cost of them? So when you're looking in menu config and it says you can turn off session ticket support, you're like, okay, you've got to do what I'm doing right here, right? Build it, compare it, and see, okay, that saves me 1,000 bytes in the flash size. I like knowing that for everything. Okay, we're over an hour now. Let's do one more. Let's try disabling some ciphers. And see what that does. You know, I'm also interested support renegotiation. Yeah, see like this. If you don't need renegotiation, disabling it will save code size and reduce the possibility of abuse vulnerability. Sorry, we're gonna do that first, and then we'll mess with ciphers. Let's disable renegotiation. Okay. Bundle on partial. Actually, let's start doing this. Same as 6. Renegotiation. Renegotiation disabled. Okay. Flash monitor. Almost there. Okay. That still works. Great. We're now at 884,637. 4. Okay, so we're like another 1,000. Like another 1,000. No renegotiation 7. So let's look at the difference between, I just don't want to type all of it. No. Renegotiation from 5 to 7. Yeah, 2,000. So like we got 1,000 on this one as well by disabling renegotiation. Cool. Okay, now let's do the last one for this stream. Let's try turning off some ciphers. I feel like there's probably a whole nother hour of messing around with cipher suites. And I'm not an expert on them, but what I know, again, coming back here to how's my SSL, like it tells you the cipher suites that your client is presenting, but also I want to grab deploy the fleet again. There's another site I learned about. SSL Labs, analyze. Oh, it's going to run it again. Okay, anyway, it's hitting app.deploythefleet.io. So this is where deploy the fleet's hosted. And I'm going to let that run. We'll come back to it. But now let's come down here to all of these ciphers, and let's make this a little bigger. Okay, all of these curves, I think you can get rid of most of them because, like, curve 25519 is, I believe, what when you initiate a TLS handshake, the client, like we see here, the client is going to say, like, here are the ciphers that I support in order of preference. The server is going to do the same thing. It's going to say, well, here are the ciphers that I support, and then it's just a matching. Like, find one that we can agree on, and then that's what we're going to use to connect. And so we're going to come back over to here. Okay, finish this. So let's look at deploy the fleet. You can do this for any website. And now it will tell you cipher suites. For TLS 1.3, server has no preference, but here are the cipher suites it supports. For 1.2, it says suites in server preferred order. And so, like, here they are. You can see total 1, 2, 3, 4, 5, 6, 7. 7 cipher suites. But if you remember from our JSON output of how's my SSL, our ESP32 is saying, hey, I support a load of cipher suites, which we have to have, that has to be built into the firmware in case the server says, yeah, I want to use that one. And then it's got to support it. Okay. But again, if you know which sites you are connecting to and they are limited and they have limited cipher suites, there's no reason to have support for all of them. And so here we go. TLS. So what I would love to figure out is how to do this. Like, here's the top TLS 1.2. The ESP32 is doing 1.2. It doesn't seem to support 1.3 as far as we've seen. Like, how can I just turn on this one? So my client says, hey, this is the cipher suite I support. It's going to say, oh, yeah, I support that as well. But I don't want to do deploy the fleet. I want to do we want to do how's my SSL, right? So because that's what we're testing with. So let's just run this really quick for how's my SSL. And then we'll see if we can eliminate a bunch of cipher suites, because I think that should decrease our firmware size quite a bit. Determining available cipher suites. That's what we want. All right, we're almost there. All right. Come on. Well, I wonder if it's not gonna show us that until it's done. Okay. In the meantime, let's get crazy and just start turning a bunch of these things off. So, elliptic curve ciphers. I'm just going to start turning off all of these, and I'm going to leave the 25519. I turned off all of them except for 25519. Let's see if that's done yet. Simulating handshakes. No. Okay, whatever. We're not waiting for it. And let's just see if it'll still work with all of those ciphers turned off. And also to see if our cipher suite that's presented to house my SSL is smaller, right? Like it was a huge JSON. Oh, okay. Okay. See, now we're starting to get dependencies here, right? Embed ECDSAC defined, but not all prerequisites. Okay. So, yeah. Probably going to be harder than we think here. Wow, their overall rating. How's my SSL's overall rating is C. That's funny. Look at all the cipher suites it supports. Insecure. And that's probably because that makes sense. I haven't given them a hard time. The point of this is for them to be able to test all these, so they need to be able to do a bunch of these. Okay. But the point being, oh, and it doesn't support TLS 1.3. So TLS 1.2, and then this 20 SHA-256 poly 1305. So this, like, what is this? Cha-Cha 20 poly 1305. If you come into here, TLS, you'll find those in here. Cha-Cha 20 stream cipher, poly 1305 MAC algorithm. So the question is, let's just turn some of these. I don't know which one of these. See, I don't know what all of these are, so I don't know what to turn back on or off, or it's kind of a guessing game. And these were off by default, but that's what it prefers. AES 128 GCM SHA-256. Let's try to build with this. Oops. Hey, it built that time. Okay. So I'm interested to see what the Cipher suite looks like. And so now we've got this same as, yeah, so definitely smaller. Oh, and look at this. The very first one is 256 GCM. So this is likely what we ended up using for RSA. Yep. Okay, well, anyway, it worked. Same as 7. We're just going to say a bunch of ciphers disabled. I'm not going to get too crazy here because we're going to wrap up. And our total. Oh, man, that actually went down a bunch. 749. Okay. Less ciphers 8. Map. Okay, so from let's go from 7 to 8. Map files plus Ciphers 8. Yeah, a bunch. And down on DRAM as well. Not much, but yeah, we lost a bunch there. So now if we go, let's go from 5 to 8. So 5 was when we went to just the most common bundles. You know, we're down 36,000 bytes just by turning off session ticket support, renegotiation, and reducing the number of ciphers. And so now let's do one final test, which is we're going to do I want to go back to like our baseline. So I want to go back to an embedded cert with all of these things turned off. Do I? I mean, I know what the difference was here. Like the most common from here was like 16, but then we went down. So we could drop, it's just a combined drop of all of these. Which is what I just did. 5 to 8. Yeah, so about 36K is what you get by just turning a bunch of stuff off that we were just messing around with. Cool. All right, I'm out of steam for one stream, but that was really, really interesting for me of how you can tweak around with mbedTLS. And you can just go into menu config and start changing all of those settings to really dial it in. Like, and that's something that fascinates me. If you're going to put something into production, you know, get it to work, but then you got to figure out how to start dialing all those knobs and levers and buttons to really optimize, because it ends up making a difference. Like I said, when you're delivering these via OTA, all those bytes cost money, depending on your scale. And it also is taking away from other code that you can be writing. You might be able to enable a feature because you saved, you know, 100K tweaking something, you know, like mbedTLS, which is such a big component that you're bringing into your project. So anyway, hope you found some of that interesting. I'm not sure what we'll tackle next on the next stream, but anyway, I just wanted to go deep on TLS. I hope everybody has an amazing rest of their day and an awesome week, and we'll catch you next time.